Okay, so here's the thing. There are so many different ways to graph a trig function. And this is one way, and that's just recognizing that there is a pattern to especially sine and cosine, to all of them. They all have a pattern, okay? Figure out where your wave begins and figure out how long a full revolution is. So if you have a phase shift or a period change, a phase shift simply means that instead of starting on the 0, 0, you're going to shift the start either left or right. And the period just changes the amount of degrees it takes to complete one full revolution. So instead of 360, it could be 180, it could be shorter, or it could be longer, like 720, okay? Now, for me, I like to think of, we know that with sine, or you will know that with sine begins at the midline. So whatever your K value is, that's where we start. And then it rotates up to the top. Then it comes back down to the middle. And then it goes down to the bottom and back to the middle. So knowing your middle, your midline, if you know where to start and you know your midline, the rest is just it's a continual wave, okay? So I'm gonna use that as a way to graph number 3. So let's look at question or example 3. So the first thing I'm noticing is that we have an A value. So A is 3. The number in front of X is 1. So that's your B value. We actually have to set this equal to 0 to get our phase shift. And our vertical change, or K, is -2. So let's figure out where our wave is going to begin, or where does it start? So let's take our parentheses, which is X plus pi over 2, and set that equal to 0. In order to solve that, you would subtract pi over 2. So that means that I'm going to begin my wave at -pi over 2. So I have a horizontal shift, and your horizontal shift can also be called your phase shift. It's -pi over 2, which means I'm going to go to the left pi over 2. And remember, pi over 2 is 90 degrees. So that means that my wave, which would start here, is now going to shift to the left pi over 2. So it's going to start here. That's where my wave is going to begin. Okay. Now let's look at how long one revolution is going to take. So in this example, B is still 1. B is 1, which is the same as your parent. So the period is 2 pi divided by 1. And 2 pi divided by 1 is still 2 pi. So for this first one, I'm going to write everything in radians and degrees. So it's 2 pi or 360. And for the phase shift, we're going to shift to the left pi over 2, which is the same as 90 degrees. So that means that if this is my start and I'm counting by 45s on my x-axis, I'm going to write that's how I am scaling it, and you can scale it any way you want to. But I am counting by 45 degrees, or pi over 4. So every single ticky mark on my graph, I'm counting it as 45 degrees. So if I'm starting here, this is my beginning, then I need to count to the right 360 degrees, and that is where it's going to end. So this would be 90, 180, 270, 360. So right here, I'm going to go ahead and put my end. because you're counting by fourths. So that is my end. Okay. So the next thing is, what is my midline? So the middle of the wave is K. And in this example, K is -2. So at Y equals -2. So every time I hit the middle of the wave, then Y is going to be -2. And remember, sine starts at the middle. So now my middle is at -2. So where I started, I'm going to put a point at -2. Where I end, I'm going to put a point at -2. And remember, sine also hits that midline right in between. So at the 180 mark, it's going to hit the midline again. And I should fill out where it says vertical shift, because K is -2, it is going to go down too. So the amplitude A tells me how far above and below the midline I'm going to go. Okay, so remember your sine wave, it starts in the middle, and it hits the top, then it goes to the middle, then it hits the bottom, and then it's back at the middle. And it's just a continual pattern. So right in between here, which will be at 0 degrees, because my amplitude is 3, I'm going to count up 3 from -2 to hit the top. So go up 1, 2, 3. So you'll be at +1. I'm going to put my point right there. And then right in between my other midline is where I hit the bottom. So instead of going up 3, I'm going to go down 3. So 1, 2, 3, put a point. So that's another way to look at it, which honestly, and we can talk about, using a table, but because it's a pattern, I'm struggling with my wave. Hold on. Okay, there we go. I know I'm just going to continue with those same 3 points. So I'm going to go from here. I'm at the -2. So now I'm going to go back up. So every 90 degrees, because we're counting by a fourth of the period. So every fourth, so for us, because the period is 360, that means every 90 degrees, we're going to put a point. So this will be my next point, and I'm going to rotate back up to +1. And then here's my next point. Then I come back down to -2. I'm going to go backwards here. Here's my point. I'm going to rotate down to -5. Here's my point. I'm rotating back up to -2. Here's my point, and I'm rotating back up to +1. And that is my wave. We don't put arrows, because if I put an arrow, that tells me that I'm going to go up forever, and that's not what happens in our sine wave. So we don't need to add arrows to our graphs. So let's fill in our missing information. So my domain is -infinity to infinity, and that does not change. The lowest Y value is -5, and the highest is +1. So my range would be -5 to 1. And the amplitude is the distance from that midline, and that is 3. So when we're looking at example 4 is cosine. Now, cosine doesn't start in the middle, because if you look at the cosine of 0 degrees is 1. That's the top of the wave. So for cosine, I know that I'm going to start at the top, then I go to the middle, then I go to the bottom, back to the middle and top. So if I figure out where to start my wave and where the middle is, then I can graph it without a T-chart or without a table. Okay, so let's go ahead and look at this function here. So it says 2 times the cosine of 2x minus pi. So to figure out where to start your wave, you start by setting your parentheses equal to 0. So let's do that. Go ahead and solve that for x. So I'm going to add pi. And then I'm dividing by 2. So x is positive pi over 2. So that tells me that I'm going to start it at positive pi over 2, which is 90 degrees. So that's where I'm going to start my wave. So it's going to go to the right. So instead of starting at 0, I'm going to the right pi over 2. Okay, so that's important. The next thing we need to figure out is how many degrees is it going to take for me to go 1 full revolution. So for me, because I start at the top, so how many degrees for me to get back to the top? So to figure that out, we need to figure out the period. So in this one, we actually have a coefficient other than 1 in front of x. So we have a 2. So the period is going to be 2 pi over 2, which is pi. So where it says period, I'm going to say pi, which is 180 degrees. So in the parent function and in all of the functions that we have done, they have all had periods of 360 because that's the parent. But now it's changed to 180. So what does that mean? So I'm counting by 45 still. That's just, again, how I'm choosing to scale my axis, is counting by 45s. And notice that they're not marked, so you can figure out how you want to scale it. But I'm counting by pi over 4 or 45. So that means that if this was in degrees, this would be 45, and this is 90, and this is 135, and this is 180. So that's what that would be in degrees. So I'm counting by 45s on my x-axis. That's how I'm going to scale it. So I'm starting it off at 90. So this is 90 degrees. And it's going to take 180 degrees for me to hit the top. So here, so that would be, this entire wave is going to be in between here. See, that's a lot shorter. Okay. So let's figure out where the top, the middle, and the bottom will be. So my K value is 0. So there's an invisible 0 at the end, right back here. So that's my K. My amplitude is A. So I am going to, for the middle, every time I hit the middle of this graph is 0 because that's K. The top and bottom, I have to add the amplitude. So my amplitude is 2. So I have to add 2 to 0 to get the top of the wave and subtract 2 to get to the bottom of the wave. So what this is telling me here is at 90 degrees, because it's cosine, I'm going to start at the top, and the top is at positive 2. And then instead of every 90 degrees putting a point, I'm going to put a point every 45 degrees. So the middle is 0. And then I'm down to -2, back to 0, back to +2. So that's 1 revolution. Okay, so we're gonna add more because we need more than just 1 revolution. So I'm gonna add, so I'm at the top. So it goes top, middle, bottom, middle, top. Hope that's the end that way. And then if I connect what I have here, this is my wave. I'm struggling with my little wave curves today. Looking a little raggedy. I'm gonna blame it on my iPad though. Okay. And then you can continue. You only need 2 full revolutions. So for us, 2 revolutions would be 360. So this is actually 2 full revolutions. But because I think that it is kind of fun to just plot points, I mean, oftentimes I'll just keep going. But on your test and homework, which I'll pass out Monday, it says you only need to do two revolutions. So the domain is all real numbers. The range is my lowest and highest y values, which is -2 to 2. My amplitude is 2. And my K value is 0, so I didn't have a vertical shift. And my midline is y equals 0. Okay, so that's it for today. I am going to stay on to answer questions if you have questions. Have a good weekend. If you have homeworks 1, 2, or 3, you can work on that if you haven't submitted it. 2 and 3, I will still take next week, and I'll update the campus page later today so you can see the updates. Other than that, I will see you guys next week.